Hello, my name is Isaac, and this is my demonstration for Project 3 of Software Development for Real-Time Embedded Systems. This project implements a simple tachometer using an IR LED and photodiode. Here in VS Code, I have my requirements that were derived from the project description. On the hardware side, we are running an Arduino Uno, and we're taking the 5 volts from that Arduino and using that to power our IR LED, which is running through 220 ohms to ground. The photodiode is connected in a reverse bias arrangement so that it operates as a switch. We have a 10 kilo ohm resistor from that 5 volt rail as well. The signal is fed into pin 2, which is set up as an interrupt pin. The configuration outputs 5 volts when the beam is interrupted and 0 otherwise. Crucially, we also have in here a little stormtrooper that's based on my 5-year-old's recommendation. Not entirely sure what role he'll play, but he's there nonetheless. For convenience and or safety, I have the LED and photodiode in a 3D printed mount that lets me keep my fingers away from any spinning objects and keeps things a little more consistent and predictable. Keeps the beam aligned and the spacing consistent. So in our code, we have a few parameters that can be adjusted. The first is the number of blades on the propeller. For this demo, I have that set to 1 because I'll be using my finger and a drill. For the drone props, this should be set to 2. The next parameter is the sample period specified in milliseconds. Because we are using timer 1 with a prescaler of 256, this value needs to stay below 1000 to make the math work later on in the program. And then that last one is the baud rate, so that can be set to whatever is needed. The program computes 2 separate RPM estimates. The first is essentially the CM Palmer method, but updated to use a timer instead of delay. The second I'm calling an instantaneous RPM. This calculates the RPM based on the previous 2 pulse times. This method seemed to be much more accurate, particularly at low RPM, which should be apparent in the output. So with that, I will upload this code, and we can jump into a couple of demos. All right, so with that done, we can start monitoring. For this first demo, I wanted to have an accuracy test. So I've got a metronome. I'm going to move my finger through the beam at this beats per minute, and we'll be able to see between the 2 methods how they do. So with that going, we'll see if I can manage 100 beats per minute. So from that output, you can see the CM Palmer method kind of jumps around between 60 and 120. So if you drop a pulse in your 1 second, right, you're going to get kind of wildly different measurements, whereas that 2 pulse method seems to give a pretty consistent timing or RPM measurement. For the next demonstration, I will throw my drill in here. I've just got a piece of black tape hooked up to my bit holder, and we'll spin that through a couple different power levels. So with that data, again, you can see as the RPM goes up, the CM Palmer method gets better and better, or closer in alignment with that 2 pulses method. But either way, both of them seem to be pretty reasonable, at least for speeds that a drone prop was going to be spinning at. Finally, I can take this data, we'll copy it out, and then we can paste that into a spreadsheet over here and have that plotted out. And there's our plot. So with that, this has been my demonstration for Project 3. Thank you for watching.